So thank you everybody for coming. Yeah, we're talking about the Creaform new and improved. What's new, what they've been coming out with, what's changed, what updates might be out there. So some of the new stuff that they came out with, if you recall, if you people are familiar with any of the Creaform product line, here's kind of the old lineup where we had the the top level portable 3D scanners and some other ancillary equipment to help doing more specific tasks or bigger tasks. So one of the main things that have been changed is the GoScan and the HandyScan have been phased out for the new versions of the GoScan and HandyScan. So now instead of the GoScan 20 and 50, we have the GoScan Spark, and for the HandyScan, we have the HandyScan Black line. And these are a bit different ergonomics, more powerful technology in them. The GoScan specifically has changed a lot to have different functionality, overall better performance, and the HandyScan has just had a lot of increases to the hardware, which resulted in higher accuracy and resolution. So let's go ahead and take a closer look at the GoScan Spark first. And here's a little video that'll kind of give us a good overview of how it works. The old GoScan worked by taking out what basically looked like a QR code pattern onto the surface. And the GoScan Spark uses 99 white light stripes. Alright, so that's a quick intro to the GoScan Spark. Compared to the old GoScan, the accuracy is up dramatically. The measurement resolution is the equivalent to the GoScan 20, which had the high resolution version, but with a much larger scan area. And also tighter volumetric accuracy. It's a really nice scanner. And as you saw in there when they were scanning that whole car chassis, it was picking it up like live data. The video wasn't sped up. Really quick, just picking up the surfaces as they were going over it, because it's getting 1.5 million measurements a second on your 15 by 15 inch scan area it's seeing. And when you're going across for that car chassis, when it has enough unique geometry in it with the GoScan, it's actually able to track geometry and texture data along with tracking targets as needed, and it can do that kind of hybrid level too. So as you're scanning something and maybe you don't have any tracking targets on it and get to a spot that might be too blank and it can't see any geometry because it's just a big flat area, you can throw tracking targets in there and then use both at the same time and be able to scan big stuff really easily. And it's a very easy system to use. It's got buttons on the back of it that make it easy to change any settings you need. Wrist straps to make it easy to hold as you're going around. You can see it's got 5 cameras on the front doing all different things from building the STL and triangulating the deformation of the surface to capturing color data. If you need it, you can always turn that off as an option too, so you don't have as much processing time you have to deal with. And it's just really fast and easy. And as you're scanning it in real time, it's going to be doing your mesh visualization, building right up on the screen as you scan over it. And when you're done scanning, you can finalize your scan and get your finished part. But you can see as you're scanning it what sections you might need to go back on and check more information for. And yeah, compared to the old scanners, it's 3 times higher resolution cameras. The color camera is higher, more dense DPI than the old ones, and improved scan surface quality. So you'll have less, bumpy surfaces and other issues you might run into. But it makes scanning stuff like, the helmet or cars or any big surfaces really easily without having to cover them with targets at a fairly good accuracy too. Now, if you need higher accuracy, the next level scanner we have for the new HandyScan line is the HandyScan Black and Black Elite are the main ones. And there's also the 307. 307 is kind of similar to the older line. It has the red laser lines. The new Black line of scanners actually has blue laser lines it lays down instead of red ones. And with those, it's able to get higher resolution and accuracy and deal with the harder to see colors, because with these optical scanners, right, it's trying to lay down information on the surface and be able to see it. And if it's too reflective or too shiny or too absorbent and you can't see those laser lines, it's going to have issues picking it up. But with the new Black and Black Elite, you can do extremely shiny and hard to scan surfaces without having to do any pre-coating or anything on them. So in this next video, we'll even see you can scan chrome wheels and stuff without having to do any powder coating on it to knock down the shine much. Get my sound going. There we go. So that's the HandyScan Black and the Black Elite, and this has extremely high accuracy and resolution and volumetric accuracy, and this is where they start considering the machine to really be a metrology grade 3D scanner. So people use this a lot for inspection, first article inspection and process inspection, and you can get extremely high accuracy results extremely quickly, because as we're scanning our parts and we're picking up 1.3 million measurements per second over the surface, you can scan large surfaces very accurately and get full surface data, not just individual little points from probing it with a CMM, and get full inspections and surface analysis of your part. So with that, we have our blue laser lines, and it's a little bit of a trade-off from the GoScan Spark, depending on what you need it for. So if you need that accuracy, you go up to the HandyScan Black. But for scanning really large stuff, it can do it. It doesn't have any of those limitations like any of those other scanners out there might have, where we can scan any size part. The thing with the HandyScan Black is that you have to use tracking targets when you're scanning your part. And you kind of see them on that picture in the middle. You see those little dots around in the surface. So it actually has to use those dots to triangulate its position. So it's not grabbing a full area in the scanning area. It's actually just only seeing where the scan lines are laying over. So it can't track geometry to figure out where it is on its own. So you have to put these targets on. So if you are scanning something really big, like a car chassis, then you have to put dots around the whole thing. But you get these extremely high accurate measurements that you can do all your metrology analysis on. But if your accuracy isn't super high for what you need to do, then the GoScan Spark could be a much better fit and save you time from having to dot up your part. It all depends what you need to do with it. And so with the metrology grade, all those scanners come with their own calibration plates that you can verify that your calibrations are good to go and up to date and haven't been knocked out of alignment. They meet the ISO accredited and VDI standards. And you can actually get these sent in every year to get recertified, so you can keep everything current and up to date. And the actual recalibrating of, so if you're using this daily, you can just run it on that example of that calibration plate with that scanner there, and it literally takes 30 seconds to verify that all your measurements are good to go. Then you can jump back in and start scanning without any downtime or in between worries of how long things are going to take or if things are still certified or not. So it takes a lot of ease off. And then with the versatility with the new lasers, so if you can scan, chrome, rims and stuff without having to do any post-treatment on the part. And then with that, you have unlimited volume too, where you can scan an entire, Boeing airplane wing. The only real limit is the computer's RAM for being able to deal with that. And if that does become something like you're scanning an entire bus, it's very easy workarounds where you can scan a big chunk of it and then just save that out to an STL file, so you get rid of the heavyweight RAM-intensive part of the scan data, and then scan the next section and scan it in sections and merge all those together later to do your inspection analysis or reverse engineering with it. So those are the two new scanners. And the other thing that Creaform came out with recently was an updated version of their VX Element software. And this is the software that runs in the backend that really controls the scanners for dealing with creating the live meshes, doing the reverse engineering, creating your inspection templates and everything. All of that is done directly with Creaform's proprietary VX Element software that were specifically designed to work with all the scanners. It's their in-house software, and they've done a couple really nifty improvements on it that make scanning a lot easier and doing any post-processing and stuff a lot easier too. One of the cool things they have, so the scanners used to have, they still have lights on the back of the scanner, so it lets you know just looking at the scanner how far away you are from the part, because you kind of have a depth of field when you're scanning a part. So if you're too close, it's like a camera, it'll get too blurry. If you're too far away, it can get too blurry, so there's kind of a sweet standoff distance. So a new thing now is, on top of having the scanner show you if you're too far or too close, on the software itself, it'll show you, so on the scan lines from the HandyScan Black being projected onto it, it'll show you green, blue, or red on the lines for if they're too far, too close, or in a good distance away. So just really easy visual feedback from looking at it to say, okay, yeah, all my scan lines or the area I'm specifically trying to get, if you're not trying to get the entire surface, is in the green zone without having to, do any guesstimating on it. Another new feature they added is the new and improved clipping planes. So they're easier to set up, easier to access, and lets you scan things more efficiently. So if you're trying to get a very high-resolution scan of a small part, if you don't have a clipping plane set up, as you're scanning that small part, you're going to be getting a lot of data of the surface and the table or whatever that it's sitting on, and that can make it a little kind of bog down the system, slow it down, because it's just more extraneous data you're picking up you don't actually care about. So what you can do is you can set up a clipping plane really easily, and or pretty much a background area, and it won't pick up any data under that clipping plane. So you set up the clipping plane right under your part. You can scan your small part. If you're scanning like your mouse for your computer, you can scan it all day and not worry about picking up a bunch of extraneous data from the table it's sitting on, and it just makes processing and dealing with your files much easier and quicker and keeps them lower weight. Another cool thing on top of that is clipping reference. So you can actually use a mesh file, a CAD, or scan as an entire clipping reference. So you can kind of set like a range that's going to clip away from it. So when you have something that might have reference geometry on it, or a cast where you don't care about things you haven't cut off of it yet, you can have that as your clipping geometry and not worry about the extraneous pieces maybe you haven't gotten around to post-processing off of it yet interfering with your actual analysis. Another one is being able to very easily deal with noise reduction. So when you're scanning something at high resolution where you're having very tiny meshes, you can get this little rough-looking surface like that picture on the left where it looks bumpy even though it could be a smooth surface, and that's just in the variation of the measurement accuracy up or down. But you can turn on noise reduction settings just from a quick drop-down, none, medium, or high. And then so there's a difference from that same part in none versus high. Just smooths things out, makes things nicer, crisper looking. Even when you're doing little tiny things like embossed writing on injection molded parts. They also have a guided workflow. So when you first get the scanner, or it's just useful to have as you're using it, so everybody uses it because they're very easy to deal with, user-friendly scanners. You don't need a whole lot of training to actually pick up and start scanning something. The workflow actually guides you through the whole process. Okay, you run through the calibration, set up the configuration so the beam power for your lasers is strong enough to get a good reading of what you want, and it's not too strong or too weak. Scan your part, and then go through the final option. It's kind of just walks you through step by step as you're running through your scan. So it makes life a lot easier works on all the scanners, and it's great for novice users if you're just picking it up for the first couple of months using the scanner, and you're like, or you only use it, every couple of months because you're not scanning things constantly. This is a great way to not get lost and be like, where do I start again? How did I do that? It just walks you through it step by step. There's even another guided workflow for the HandyScan Black, where you can do small parts, where it'll actually guide you through the process of scanning one side of it. If you flip your part over, you scan the back side of it, and then you can merge those two scans together into one part, so you can get both sides of your small part that would be difficult to mount up in the air, so you can scan around it in one go. And that's something that can be a little trickier, so it's nice that there's also guided workflows for that and walk you through what's happening. And they also have scanning templates now in the software. It makes it very easy to set up clipping planes, positioning targets. And these are things, if you have something like in this picture here, where a reusable jig that has targets already on the jig, not specifically on the part. So the targets are going to be in the same point every time. Your clipping reference planes will be in the same point. You're going to be using the same scan parameters. You can save all that into a scanning template. So every time you're going to scan another one of these parts, you just open up that template, and you can jump right in, scan the whole thing in a couple minutes, and you're done. And then it'll kick out an inspection report in a couple seconds, and you have that entire part inspected without having to fiddle around with setting up any of these things that you'd have to set up every time. You just save it all in the software. But yeah, don't want to waste too much of your time, so that is a quick overview of what's new with Creaform, from the scanners to the software. If anybody wants to come and see them, we're always happy to set that kind of stuff up.
Also, you can find more information on our website, cati.com. Check out our blogs to see some applications from our technical resources. Also, check out our events page to see the scanners live. We do have a What's New with 3D Scanning workshop going on in Buffalo Grove, Illinois, and in Ohio, Cincinnati, along with various other events throughout the country where you guys can actually see these live and maybe get some hands-on experience. All right, Tim, looks like there's a few questions coming in here. So one question was, how does it do with threading and black surfaces?
Yeah, so with black surfaces, it actually does really good nowadays, depending on the level of scanners. So the higher you move up in scanners, so the Spark to the HandyScan to the METROLOGY, it just does better and better at them. So pretty much the HandyScan, shiny black surfaces are like the hardest for optical scanners to deal with in general. But the HandyScan, it actually does a really great job. I mean, I've scanned shiny fiberglass parts before without having to coat them or spray them or anything. And that's always an option. If you do get something that's like, has a mirror finish on it, you can always hit it with, some sort of temporary spray that you can just wipe off really easily to knock down the shine. But as far as threads go, it just depends on the, how fine they are. If you're talking big threads for giant stuff, you can do it easily. Finer threads, you're going to start running into some issues on when they start getting too fine detail. If we're talking like, machine 20 and stuff like that. Generally, once you get your thread data, you don't really need it in the scan. We'll be able to grab the cylinder size and everything from it really easy, and then you can always apply the threading for reverse engineering or something in the CAD program.
Perfect. All right. That's it for today's webinar. I appreciate your time, Tim Crennan. Again, check out our local resources for further information. Thank you, guys.